Okay, recording now. This is part 2 of lesson 3.5, multiplying whole numbers by decimal numbers less than 1. Before watching the recording, please make sure that you have a graph sheet of paper in front of you along with a pencil, a straight edge, and different colored pens if you like. So if you need to pause the recording to get those items, please feel free to do so. So I'm just going to continue, and I'm going to start off by doing some review from last day. So from the previous lesson, you would have encountered questions like this. So you would have multiplied something like 89 and 98 hundredths times 9. So remember, leading up to this lesson, you've done a lot of work with estimating your answer before you actually multiplying it. And remember, we talked about the importance of estimating so that you're not just blindly putting the decimal point in your product without thinking why it should be there, right? So you're making that connection with the different types of estimates. So I actually want you to pause the recording right now, and I want you to estimate yourself. Maybe perhaps give two different estimates for 89 and 98 hundredths times 9. I'm going to continue, and I'm going to change colors because I know you all like aesthetic notes. Okay, so here we go, estimates. So let's do, I'm going to do one estimate at being 90 times 9, which would give me 810. What type of estimate is this? Well, you could argue that it's a decimal benchmark because you are following the rules of rounding. Or you could also say that, well, it is just a decimal benchmark, I suppose. You could argue maybe it's compatible numbers too because of the 9 times 9 in there. Is it over or under? It is an overestimate. Maybe you came up with a different estimate as well. So maybe you did, let's say, 89 times 10. And that would give you 890. I would say 89 times 10 is compatible numbers. And hopefully this rings a bell from a previous lesson. Is it an overestimate or an underestimate? This would probably be I would think it would be, you know what? I'm going to say this is going to be an overestimate because even though you took 89 down to 89, because you went up to 10, it will actually end up being an overestimate, okay? But just so you know, and just so you're aware of the different types of estimates, and always be aware if you are under or over the actual answer. So when you actually multiply this out, I do want you to multiply this out. So go ahead and do this up here and multiply and figure out your answer. You can pause the recording before I go over the multiplication, but I'm going to continue. I'm going to do the multiplication one way, and then I will do the FOIL way for those of you who use FOIL. So I'm going to do the first way. So I'm going to take from the last column on the right hand side here. 8 times 9 is 72. Oops. Carry the 7. 9 times 9. 9 times 9 is 81. Plus 7, which would give you 88, and then you carry the 8. And then you've got 9 times 9, which is 81, plus 8, which is 89. Carry the 8, and then you've got 8 times 9, which is 72, plus 8, which is 80. Okay, so again, you're looking and you're comparing your estimates here, right, to what you actually got as your product. 809.82 or 80,982. So you know your answer has to be around 810 or 890. Therefore, you're putting the decimal place between the 9 and the 8 so that your product is 809 and 82 hundredths. I know some of you do FOIL. Now, if this is a confusing method for you, that's fine. You can just listen. You don't have to copy this down. But for those of you who embrace a different method, and we always go for different strategies in math, whatever works for you, what is the most efficient. So if we're taking 8, okay, let me do this in a different color here. If we're taking 89 hundredths, 98 times 9, remember that we forget the decimal as well, right? So this becomes, and what we do with FOIL is that we expand the numbers, right? So we expand the first number. So really this is actually 998 times 9. So we go 8,000 times 900 times, oops, not times, oops. That should be plus 900 plus 90 plus 8 times 9. So when you have a bracket touching a bracket, it means multiplication. I am going to go through this pretty quickly. So FOIL is first, outside, inside, oops, inside, and last. Okay. So the reason why FOIL is introduced is because it helps you to multiply binomials later on in upper levels of math. But if you're not ready for this, that's fine. Or you prefer to stick to this method, that's totally fine. Again, different strategies are welcomed. So you do first, inside, outside, last. So you're going to do first, which is 8,000 times 9, which is 72,000. And then you do the next one, outside, which is 900 times 9, which is 8,100. And then you do 90 times 9, which is 810. And then you do 8 times 9, which is 72. And when you add it up together, again, you can pause the recording if you wish. You should also get 289. And then remember, you place the decimal point based on our estimates above. Same answer is there, okay? So that's just a review from 3.4. We are going to move on to 3.5. So 3.5 involves multiplying whole numbers by decimal numbers less than 1. So what happens, you can jot this down, what happens when you multiply a whole number by a decimal number less than 1.
Hi.
Okay, that's Aiden. He's saying hi. Obviously, I'm at home. You can say hi again.
Hi.
Do you like math, Aiden?
Yeah.
Okay, it's his favorite subject. There you go. He takes after his mom. Okay, so what happens when you multiply a whole number by a decimal number less than 1? Okay, so say we've got this question here, and hopefully you've watched the previous lesson video on the patterns when you're multiplying by a whole number by a decimal number that's less than 1. Okay, say you have 254 thousandths times 7. Now, I always say to you estimate before you actually calculate, especially when you're when you're multiplying with decimal numbers. But it's a little bit trickier to estimate. So I'm not always going to require you to estimate, only when you're multiplying by a whole number that's by a decimal number that's less than 1. In all other cases, I always expect you to estimate. In these cases, it's a little bit more tricky, but there is a way to do it. Well, how are you going to get to a reasonable estimate like this for this? So I'm going to write it off to the side here. Okay. There's a few ways you can approach it. So really, if you do if I took the decimal and I did an over and an under estimate, it's not very helpful. So say I get 1 times 7, which is 7, or I get 0 times 7, which is 0. Are these really helpful? Well, no, not really. But what I could do is I could maybe take numbers that are easier to calculate. So for example, maybe I'm only going to take, say 2/10 times 7, right? Now, can I do that? Yeah, I can do that. You know that, again, from the previous video, you take the numbers that you know are going to be in the answer. So if you know 2 times 7 is going to be 14, right? You know your answer is going to have a 1 and a 4 in it, or your product's going to have a 1 and a 4 in it, because 2 times 7 is 14. But is your answer going to be 14? No, because you're multiplying by 2/10. Where is your decimal going to go? Well, I only have one spot after the decimal here, so therefore there has to be one spot after the decimal here. What if I took it to 3. So say, for example, maybe I rounded 2/10 to 3. Because remember, we can be flexible with our estimates. Maybe I did 3/10 times 7. Again, I know in my head 3 times 7 is 21. My answer is not going to be 21. It's going to be 2 1/10 or 2.1 because I'm multiplying by 3/10. Now, what you're going to do is the same thing as before. You're going to follow the same strategy. What you're going to do now is you're going to multiply this. You're going to forget the decimal. So go ahead and multiply 254 thousandths times 7. I'm going to continue. I'm going to do it one strategy, the first strategy I used in the previous question. 4 times 7 I know is 28. I carry the 2. 5 times 7 is 35. Plus 2, which is 37, carry the 3. 2 times 7 is 14. Sorry. 2 times 7 is 14 plus 3 is 17. Carry the 1. And then 0 times 7 is 0 plus 1 is 1. Now, I'm looking at my estimates here. And I know my answer has to be between 1.4 and 2.1. Well, then I know if that's the case, then the decimal has to go here. So it's going to be 1.778. Okay. Now, there is a way to check your work, and I'm okay with this too, is that when you're actually multiplying a whole number by a decimal number less than 1, you can count the number of decimal places. So you know that there are 3 digits after the decimal in the number you multiplied. Therefore, there has to be 3 digits after the decimal in your product. But do not just rely on that. Try to estimate when you can, okay? Here's another one. Okay, so a little bit more tricky, but doable. So let's do a decimal number like this. Okay, so now we've got, and this is a good review of your decimals, right? Now you've got 757 hundred thousandths times 5. Well, again, how are you going to estimate this? Well, okay. I know that I've got, okay, let's just deal with maybe the first digit. That's not a 0. That's after the decimal. It's a 7, right? So I could go 7 thousandths. Oops. I could go 7 thousandths times 5. Okay, again, I know from my previous, the previous work I did, I know if 7 times 5 is 35. I know I'm going to have a 3 and a 5 in my product, but my answer doesn't make sense as 35 because I'm multiplying by 7 thousandths. So I know that because I'm multiplying by 7 thousandths, it's going to be 0.035. How did I do that? Well, I know that 7/10 times 5 is going to be 3.5. And I know that 7/100 times 5 is going to be 35/100. That's how I know that. Okay. So I'm just going to leave it at that. I know that my estimate is going to be around 35 thousandths, or sorry, yeah, 35 thousandths. So then what I'm going to do is I'm going to multiply this out. And again, you can pause the recording if you want to practice. I know when I multiply this, 7 times 5 is 35 plus 3. 5 times 5 is 25 plus 3 is 28. Carry the 2. 7 times 5 is 35 plus 2 is 37. Carry the 3. 0 times 5 is 0 plus 3 is 3. And I know it'll be a 0, 0 there. And I look at what I have as I estimate. I know the decimal place has to go here based on where the decimal place is there. So that is my product. Okay. Finally, with something like this, well, this is actually a little bit easier example here. So say you've got this, 8/100 times 6. I mean, how do you estimate this? Well, you could, if you want to, although this one, the calculation's a little bit more straightforward because of the 8 times 6. You could take it to 1/10 if you want to, because you could round it to the nearest tenth, because 8/100 would become 1/10 times 6, which would give you an answer of 6/10. But you know that if you actually multiply this out, 8 times 6 is 48, right? You know your answer is not going to be 48. You know your answer is not going to be 4 and 8/10. It has to be 4800ths. You can go by, again, the number of decimal places in the decimal that you multiply by. So again, just to reiterate, and you wrote this down in the previous video, but we'll write it down here, is that when you multiply a whole number by a decimal number less than 1, the product is less than the whole number you multiplied by, or the whole number multiplier by. The whole number you multiplied by. So again, am I always going to expect you to estimate in these specific cases? No, but just know that there is a way to estimate. It is trickier, but it is possible. But just the practice of estimation is important, and being mindful of where you place the decimal point in all of these cases, okay? Because you have to be mindful and always think about what makes sense in your answer, right? Where does the decimal place go in order for your answer to make sense?